I've opened up the sample Blink sketch, which is going to allow us to do what you did in the classroom when you were testing the board and the connection between you and your laptop and the board. It's exactly the same program. We've got the sketch supplied by Arduino. It's a functional sketch. Timings are here, and let's just go through what the sketch is doing. Sets up pin mode 13 as the output pin. Now we're going to use exactly the same pin because that's mirrored on the Arduino Uno board with an LED which will flash as pin 13. In the loop, we've set up pin 13 as the output pin, set it to high, that means turn the voltage on, wait a second, turn it off, wait a second. So it's going to flash on and off with a second interval between on and off. So that's what's going to do. I've set up my board, it's on COM port 4, and now I'm going to just compile the sketch. You can see it's compiling in the bottom right hand corner, and now I'm going to transfer that onto my Arduino board. Once again, in the bottom right hand corner you'll see the progress bar, and all is now on the board. So here's the simple sketch running on the Arduino Uno on one of the rigs that we've got. I've got my USB connected here, as you can see. That's where the power for the board is coming from at the moment. You can apply an external power source there. Yeah, you can do that. Absolutely, you can do. And that's what you might do if you had very high power drain on a motor, for example. So here's our simple LED. It's flashing. That's pin 13 mimicked onto the hardware of the board. So it's a really simple demonstration that you can make a sketch, control hardware. Let's look at the circuit we're going to create. This is a really crude drawing at the moment, and you're going to get a much better set of tools that you can use to make really sophisticated drawings. So I just want to point out the elements that I've created in this particular drawing here. Okay, this represents our Arduino, and the USB's on this side supplying the power. It's actually up here more effectively on the board. These are the digital pins on this side, and we're going to use pin 13, and we're going to connect that to the breadboard. Now on this side of the board we've got the voltage supplies, and down here on the board you'd have the analog terminals for the board. So this represents our breadboard. Now in this side of the breadboard here, normally you've got the positive and negative bus that you can use, but this is so simple that we don't have to use that. We could mimic the positive and negative bus, but in this case we're not going to. So we're going to have the breadboard, and on each strip of the breadboard, I'm going to show you that in hardware in a moment, we're going to connect between two strips of the breadboard an LED. Now it's important to note that an LED has what's called polarity. It has a positive and a negative side, and the positive is the anode and the negative is the cathode. An LED is represented by this symbol here in electronic circuits, an arrow pointing to a plate, and the arrow is the positive and the negative plate is the cathode. Now in the physical device, the longer lead on the LED is the positive anode. Longer is positive, longer is positive. So we connect our LED between two of the strips on the breadboard. Now, because the supply of voltage here is 5 volts, if we use that 5 volts untreated, we could damage the LED and perhaps the circuitry on the Arduino. So what we do is we put a resistor in line with the positive terminal of the cathode. This protects the board and the LED from being burned out. You could get away with it probably in most cases, but it's just not worth the risk. Now the value of the resistor that we're going to use is a 220 ohm resistor, but I've found that actually it'll work up to, 10k on resistors. So kind of any resistor you've got lying around is going to be better than none. And in fact, you should use different resistor values for different types of LEDs in terms of the color of the LED. We don't have to worry at this stage. We're just going to use this 220 ohm, which is a good average for any LED setup. So that's what we're going to create in hardware. A board, a breadboard, 2 jumper leads, and an LED. And I'm using a red LED just because it was the first one that I picked up. So here's the circuit wired up in the hardware. This is a kind of very crude circuit, as you can see. We've used 2 jump wires, one black and one brown. It is conventional that you would use the ground as the black, and if you were supplying a bus voltage to this line here, this positive line, you would conventionally use a red jump wire. It makes no difference to the functionality, of course. Let's just look at the circuit as it goes. From my ground terminal here, I have connected to the cathode the shorter leg of the LED. I don't know whether I can do this and take it out and show you. The cathode has the shorter leg. So I'm going to put that back. On the anode side of the LED, in line with the anode, I have put a 220 ohm resistor, and at the end of that line of the breadboard, I'm connecting that terminal to pin 13 on the Uno. So that's my circuit. Ground going back to pin 13, where the signal is coming from the LED. Now on my Uno board at the moment, the LED program is already functioning, so I'm just going to demonstrate what happens when I connect. It's already loaded. When I connect power to my Arduino Uno, it will immediately run the program. So it's just establishing the connection, and I'm now getting on my LED a flash every second. I see a slight difference in phase between that one and that one, and that's just the simple timing of the operation that's happening. It has to go through the circuits. It's not instantaneous. It's as near as you can get to instantaneous, but it's not instantaneous. Forgive the brightness of this LED, and forgive also in this camera setup that I have the fact that when I move anything, because I'm using such a high resolution, I do get a sort of a drag effect until the camera settles down. It's not easy for me to show you these pieces here, but you'll see that when we use the more sophisticated software that we're going to use, this is eminently clear when we use the software, the drawing software that we're going to go on to in a couple of videos' time. So there's my blink using an external LED. The important points again: protect your LED with a resistor. 220 is perhaps not exactly right, but it's kind of okay for this one, and it's doing a functional job on that. My sketch is running with the break of a second, and if I change the LED, I won't do it, of course, because you can just play with that, then the blink rate will change. So that's the blink rate using, or the blinking LED using an external LED.